Okay, so chapter 3 is about momentum and impulse. You need to be able to define. So there's two subtopic, 3.1 and 3.2. 3.1 is that you have to define J equals to F delta T, and then solve problem that you have graph of FT. Okay, and then for 3.2, you have conservation of linear momentum. And then elastic in elastic. Okay, so most of the topic in this chapter actually you already learn in school. Okay, either kamu ingat tak ingat lah. So sebagai example, this one you guys already know. The graph of F against T, I'm not sure whether you guys learn in this one in school or not, but the formula for this one for sure you guys learn. Conservation of linear momentum. Momentum is conserved, that one you learn in school. One dimensional you did do in school, two dimensional maybe not, but it's okay. And then we have elastic and inelastic collision, similar with your school but ada sedikit perubahan lah, and then I will show you juga, so shouldn't be a problem. Okay, for today, J here, maybe you can define a little bit lah. J is actually your impulse. Okay, and J is actually equals to F delta T. So if you want to read the definition, you can read in your lecture notes lah. Ada dalam lecture notes, tak ada masalah. So F here is the force, delta T is the time they interact. Contohnya, let's say if I throw a ball, and this ball will bounce back. Okay, the time dia touch dia punya surface tu is the delta T, the interaction time tu. So the longer the time, so you will have a different force. So obviously dekat school kita dah belajar kan, kalau kita ada delta T tu, contohnya paling yang obvious I think kalau kereta yang crumple zone tu. So if a car involved in an accident, katakan car ni dia nak langgar flat surface, what is the criteria for the crumple zone tu dekat hood ni? You guys still remember or not, Form 5 ni chapter? What is the criteria to minimize the impact towards the car and the person inside the car? Guys?
Just fikir.
Apa dia? Tak dengar?
Kalau yang dalam tu ada airbag.
Ada airbag, okay. Apa tujuan airbag? So, your friend say this one airbag.
Memanjangkan impas.
Okay. Increase the, memanjangkan impuls. Increase the time kan? Tanya. Time of accident ataupun time of interaction tu lah. Selain? Apa lagi ada?
Panjangkan
Tali pinggang.
bambu.
Tali pinggang, okay. Sudah. Tadi siapa yang nak cakap tadi? Fadilah.
Panjangkan bambu.
Panjangkan apa?
Bambu depan.
Okay. So, sudah. Okay. So longer hood. Okay. All of this actually, the main reason ataupun the main objective this being applied is so that to increase the time punya interaction to delta t actually. So what happens that J here is actually equals to change of momentum. Okay, so it really depends on the velocity. Okay, so P here means momentum, delta here means change. So this one is change in momentum, which is basically final velocity minus initial velocity. So if in our drawing here, this would be your initial velocity, which is in this direction to the right. Your final velocity would be in this direction. So you will get a negative V to the left. Remember that. So as long as you have a constant value here, your J will have a constant value. Okay. But if you want to have lower force, this one is the impact force. The force that can be felt on the person ataupun on the ball here. You can either increase or decrease. So you can imagine that if this one is 10 and delta t is like this, so you get the numbers 10 from this equation. You get 10, so it's a constant value. And if you increase the delta t, what will happen with the f? Kalau delta t naik, f ni jadi apa?
Naik juga.
Naik ke turun?
Oh, dia turun. Okay.
Turun kan? So katakanlah contoh kalau kamu still tak nampak, let's say I put numbers 2 over here. So if delta t is 2, f is 5. But if delta t is 3, this one becomes what? 3 point. So 10 divided by 3 becomes 3.33. Understand? So as this one goes up, this one becomes smaller. So if we increase the delta t, you will expect f will be smaller. Okay, so for any question?
No question, sir.
Okay. So for your syllabus, excuse me, normally they didn't ask about application. Jarang tanya pasal application. So most of the time when we learn about application is for your understanding. Macam mana kita nak faham lah. But in exam, normally they will ask you about calculation. So I already defined this one. So we're going back to the learning outcomes. So hopefully you guys understand lah. This one is what and this one is what. And then graph of FT. Okay, and one more thing about this one is the unit. So if you want to do the dimension analysis for unit, okay, you can do J, which is equals to F, which is basically force multiplied by time. So that one will just be NS. Okay, so the SI unit for impulse is Newton second. Itu je lah. And then for your syllabus, you have a graph of F against T. Okay, I think if you are looking at your lecture notes, you will see that they give you a graph something like this. Kan? Macam a curve, something like that. Tapi in reality, kalau dalam exam, kalau dia tanya, dia akan kasih a straight line. Ataupun a shape yang boleh kira lah area dia. Example is like this. Okay, katakan this one is 0 second, 2 second and 4 second. And the total force here would be, let's say, 10 Newton. Okay, let's say the question want you to find the impulse. It will be area under the graph. Okay, because this one is too straightforward. Sometimes they change the situation a little bit lah. Yeah, just wrote the answer first. area is equals to half multiplied by height multiplied by base. So it will be 20. Okay, so this is an example lah. But as you can see, this one is too easy. So most of the time they will change a little bit. Contohnya they give a situation lah. Macam cerita tadi tu yang macam ball tu kan. And then they give you the initial velocity, final velocity, and then they give you a mass, and then they want you to find this force. So dia terbalik sedikit. So they give you this information so that you can find the J, and then you can relate with this equation so that you can find the force. Maybe kamu tak nampak lagi, nanti kalau kamu dah dapat soalan kamu nampak kot. And even for this kind of question, maybe they will ask you to find the U and V. Okay. Okay, U and V is very interesting because it involves with the direction. So I'm going to show you one example. So this one is example 1. Okay, so this is example 2. Let's say find the force. Let's say find impulse on the ball. Straightforward question, tak ada masalah pun. You guys okay ke tak ni?
Okey, sir.
Okay,
Ya,
sir.
Dah bangun belum ni?
dah.
Dah.
Rasa
Sempat mandi ke tak?
Sumpah saya sempat.
Astagfirullahaladzim. Okay, contohlah this is, let's say this is a tennis ball. Okay, we do the simple one. Okay, find the impulse on the ball if okay, cuba kira. Hopefully you can understand my writing. Find the impulse on the ball if initial velocity is 10 meter per second and the final velocity is equals to 8 meter per second given that the mass is 200 gram. Okay, let's say this is question A. Okay, cuba buat. Ya, A tu kamu nak pakai apa?
MV minus MU.
Okay. Okay, you can use impulse because impulse is basically J. J has two formulas, either F equals to delta T or equals to delta P. So for the first question, they did give you the velocity and all, including the mass. So the easiest way is to use delta P here. So delta P is equals to mv minus mu. Okay. So my suggestion is that you can always try to redraw. Sometimes, most of the time, dia punya diagram ni tak berilah. So you have to draw it yourself. You can imagine lah, kalau dia baling kat wall, tak kisahlah wall dia belah kanan ke belah kiri. Once they rebound will rebound in opposite direction. Okay, so your U here is equals to 10 meter per second. Okay, your V here would be equals to 8 meter per second. So J is equals to mass. Maybe I can factorize V minus U tu. So 200 gram saya nak tulis kat sini apa?
0.2.
Okay, good. 0.2. Kenapa 0.2? Because this is your SI unit. So you have to change mass to SI unit. So M is equals to 0.2 kilogram lah. Everything is in SI unit. Okay, because if you want to write the final answer in Newton, it would be SI unit. Okay, V kita
8.
U kita
10.
10. Okay, betul ke salah? Okay, kalau saya cakap ada kesalahan, mana salah dia?
Negatif 8.
Yes, negatif 8. Kenapa?
Sebab dia berlawan arah. Change in direction.
Sebab dia ke kiri actually. So it depends on your drawing. Kalau saya lukis wall saya dekat sini and my U is in this direction, so my U would be equals to negative 10. But since I draw it like this, it depends on your drawing. Tak kisah pun, jawapan mesti sama dia akan sama jawapan. So in this case, U is positive because it is moving to the right, okay, and V is negative because it is moving to the left. Okay, kamu jangan ingat dia opposite ke tak opposite you just think that positive is to the right, negative to the left, itu je. And it is based on your drawing. So this one will be negative 18 multiplied by 0.2. Negative 3.6. What is the unit for this one?
NS.
Okay, NS. Okay, what is the direction of the impulse?
To the left.
Yes. So impulse is a vector as well. So impulse is 3.6. Okay. And obviously you get the answer to the left because of your drawing. Question B. If the ball touch the surface for 2 milliseconds, find the impulsive force and its direction. Okay, how do you want to find the impulsive force?
Kita dah dapat J, so guna formula FT.
Okay,
F tu kita nak.
alright, correct. So you can find F using J divided by delta T. Okay, so since this one is to the left, you can substitute negative as well over there. Delta T is equals to 2 milliseconds, which is 2 times 10 to the power of negative 3. Okay, that one is prefix. Chapter 1. So ada yang masalah with the prefix tak? Midi, kilo, micro, okay kan?
Okay, so okay.
So I got here is 1800 Newton. I got a negative as well. So what does it mean by this answer?
Force dia ke kiri.
Okay, correct. So all vector quantity, my suggestion is that you write down the answer again lah, macam ni lah. You write down the statement macam exactly saya tulis ni. Okay. And you can see that the force and the impulse is actually in the same direction, which is basically the opposite direction to the incoming punya velocity. So it is actually normal to the surface. If I want to draw it over here, both my J and my F is in the same direction, and both of these is to the left. Okay, normal to the surface. So it makes sense lah. Kalau kamu langgar dinding, force tu rasa dekat kamu in that direction. So everything makes sense. Any question?
Tak ada, sir.
Tak ada. Okay, and then 3.2 we have conservation of linear momentum, which might involve one dimension and two dimension. Maybe we can try to discuss one dimension first, and maybe I can try to show you what happen if you have two dimension. But most importantly, I want you to point out about elastic and inelastic punya collision. Dia ada kriteria dia lah. So actually 3.2 is about collision. Actually tajuk dia apa 3.2 kalau kat sini kata conservation of linear momentum. Okay, I'm gonna change it. Okay, so kalau dekat sekolah kita cuba tengok benda yang biasa kita belajar. So normally we have a situation like this. Example, okay, in case kamu ingat, tak ingat lagi lah. Okay, let's say if you have object A, object B, okay, so object A is moving in this direction, object B is moving in that direction. Let's say the velocity of A is equals to 10 meter per second, and B, let's say, is 2 meter per second. Okay, and then let's say the mass over here is equals to 2 kilogram, and the mass over here is equals to 1 kilogram. Okay, so this one is before collision. Okay, normally in your question they will give you in sentence lah, and you have to redraw the situation. For me, I would personally draw it like this: before the collision and after the collision. So normally student dia tak lukis before and after. Instead dia just buat arrow. Arrow dia ada lukis satu je, dia tak bezakan before and after. So end up dia confused. So let's say after collision, ini pun maklumat, this one we get from the question itself. So let's say final U is equals to, sorry, V, now it's V. This is object A, this is object B. And the question want to find the velocity of B, sorry. Okay, since this one involves lots of information, you can see that you have velocity, initial velocity you have 2, mass you have 2, and velocity final you have 2 as well. So you really need to put a subscript. Okay, so example here, zoom in a little bit. When you write down the U, you need to write down this one UA or UB. Okay. The mass you have to write down lah, mass of A or mass of B. Okay, and then direction, make sure you put down the arrow. So I differentiate between initial and final velocity by using U and V. Okay, so far any question? Soalan tak?
Tak ada sir.
Okay, what is the conservation of linear momentum? What does it mean by conserve?
It's constant.
Apa yang constant? Kalau
Total momentum dia.
conservation is constant, yes.
Total
Sorry,
momentum
apa?
dia constant.
Total momentum is constant, correct. Okay. So in this case, conservation of linear momentum means that total momentum for initial is equals to total momentum for final. And since we know that P is equals to mv, so you can substitute this one inside this conservation of momentum. So for your syllabus, memang everything is conserved, especially the momentum, momentum, energy is conserved. So in real world, it might not be conserved lah, tapi dekat sini kita assume dia conserve. Okay, so you can do this one. Total, okay. Notice that I put this one as total. Summation of initial momentum. Kenapa ada summation of initial momentum? Because initially you have two momentum. One comes from the object A, another one comes from object B. Okay, so this one is actually P A initial plus P B initial equals to P A initial plus momentum object B final. Salah tulis saya tadi. This one is final. Oops. So final for object A, final for object B. Okay, this one you really need to write down dekat your punya answer, because sometimes this one ada markas satu konsep. So write down lah. And this one you don't have to. Ini tak perlu. Tapi biasa saya tulis, first time ni saya tulis lah, lepas ni saya skip yang ni. And I'm gonna go straight to MV dengan MU. So initial we represent with U, and final we will represent with V. Okay. So we have initial momentum A, initial velocity for A, mass B, U. Okay. The subscripts is really important because if you didn't do, nanti kamu confused, especially kalau kamu buat the two dimensional. And this one is still one dimension. Dia punya collision tu dekat satu dimension lagi. Hanya X, dia tak ada Y. So maybe we can try to substitute. So if you substitute, then you will get Okay. Betul ke salah?
Salah.
Kat mana salah?
Dekat yang 10 tu dia negatif. Jap, mana eh? 2. 2 tu kena letak negatif sebab dia ke kiri.
Okay. Betul. So very good. Okay. Yang lain apa cerita? You guys stay here. Madi ada?
Yes, sir.
So what do you think? Madi? Now is it correct or atau ada salah lagi?
Betul kot.
Ha? Apa dia?
Betul kot.
Betul. Firas?
Nampak betul.
Nampak betul, okay. Okay, cuba kita kira. Kalau kita rasa betul, kita kira. So it will be 10 minus 2, which is 8. And then you minus with 6, you get 2. So VB will be equals to 2. Betul tak? So 20, saya kira ni. 20 minus 2, I got 18. 18 minus 6, we get 12. Betul ke tidak? No.
Betul sir.
Betul Okay, how about the direction for VB?
To the right.
To the right.
Kenapa?
Positif.
Yes. Okay. So every time you find an answer, you just write the direction to indicate this one is a vector lah. To the right. Okay, so it makes sense. Kalau kamu nak typical logic, okay, you have a heavy object, heavier compared to the others, and then it has a higher velocity compared to the others. So kalau kecil-kecil kamu main langgar kereta kan, obviously yang this one akan menang lah. Okay, saya cakap dia menang tapi tak ada menang kalah here. So in this case, this one will determine the direction for this one. Since this one end up to the right, so this one will be to the right as well. So it makes sense. Okay, so far it makes sense. So this one is based on conservation of linear momentum. Okay. Now, we want to determine whether the collision is elastic or inelastic. Okay, so how do you determine whether this one is elastic or inelastic?
Kinetic energy dia sama dengan sebelum dan selepas. Kalau elastik.
Okay, so kalau dekat sekolah dulu, kita belajar elastic collision dia tak melekat. Inelastic dia melekat, betul ke tak? Ke kamu dah berubah syllabus?
Betul sir.
Betul
Betul.
So masa saya belajar dulu lah, saya rasa sama juga kamu still learn it like that. So dekat sini dia lain sikit. It's nothing to do with the whether dia melekat or not. So it's everything to do with the conservation of energy. Exactly macam Baki cakap tadi. So criteria for elastic and inelastic, both of these will have a conservation of energy. Momentum is conserved. So this is the first criteria lah. This is the persamaan between the elastic and inelastic. The difference is that for elastic, kinetic energy is conserved. Betul Bakis?
Yes sir, betul.
And this one is not conserved. Okay, I might have to double check. Dah lama saya tak ni. Kadang-kadang saya pun tukar. Tapi rasa betul. And Pakis pun cakap betul. Elastic is equal, inelastic is not equal. Okay, correct.
Betul, sir.
Okay, right, good. Okay, so if you guys still remember, what is the formula for kinetic energy? Kinetic energy K, apa formula dia?
Half mv square.
Yes, half mv square. Okay, so kalau initial kita pakai half mu square lah. Tapi in general, the formula is half mv square. Okay, and then one more thing, we have another thing. Kalau benda tu melekat, let's say they collision. After the collision, they move together. That one is what we call a perfectly inelastic. Okay, itu nama je, perfectly inelastic, where okay. So let's say if you have, let's say you have a situation and you calculate, you can determine whether it's elastic or inelastic based on the kinetic energy there. And once kamu dah tentukan, kamu tengok they actually move together. So you can call that one as perfectly inelastic collision. Okay, tapi term ni syllabus kamu jarang saya pakai, but I just show you because this one ada dalam nota, so saya sebut je lah, tak ada apa pun. Pernah kot satu ketika dulu lah dia kasih yang this one, the word perfectly inelastic collision tu dalam soalan. So student need to know that the kinetic energy is not equal and dia melekat lah afterwards. Okay, tapi dalam exam most of the time yang kriteria yang diberi dalam soalan tu elastic tu, you need to know yang this one. Nanti kalau kamu jumpa soalan kamu tahu kot. Okay, now we want to check whether our collision, this one over here, is it elastic or inelastic? So biasanya the next question that we ask you determine whether the collision is elastic or inelastic. So I'm going to write down the VB that you got just now. Okay. And then copy everything because we want to determine whether this one elastic or not. Nak example apa Oh, this one actually is example 3 for today. So cancel out 3. And this one is example 4. Okay, so hopefully kita covered all the question except the 2 dimension. So that after this you can straight away do the tutorial. Determine whether the collision is elastic or inelastic. So basically you want to determine whether the kinetic energy is conserved or not. So to do that, you can calculate summation of Ki and summation of Kf separately. Left and right tu kamu buat separately. Contohnya like this lah. K initial is equals to half mu square plus half mu square. One of these correspond to object A, another one correspond to object B. We can do straight away, calculate it. So I can factorize the half. Saya buat half tu ke depan. So mass of A is 2 kg. Velocity of A is 10. Don't forget to put the square. Plus 1 kg and 2. Again, don't forget to put the square. So I got here is 100 multiplied by 2, 200 plus 4, 204 divided by 2, I got 102. Okay, kalau saya salah betulkan saya. So this is kinetic energy, so the unit will be apa?
Joule.
Yes. Okay, so this one for before collision. So final is equals to half mv square plus half mv square. Again, this one's for A and this one's for B. So important for you to use the subscript. Dia tak ada markah untuk subscript, tapi tulislah. So for after the collision, we have to choose the information from here lah. 3 and 12 over there. Okay, I just double check all the information whether it's correct or not. Macam okay. Okay, so 9, 18 plus 144. Berapa tu? Awak. Okay, kita tak boleh fikir. Pagi sangat nak fikir. So I got here is 81. Did you get the same answer?
Dapat sir.
Okay. So, what can you conclude with these two? Apa yang kamu boleh simpulkan?
Dia inelastic.
Okay. So just divide this section. Okay, so since summation of Ki, is it equal or not?
Not equal.
Not equal, so you just put it like that. So if it is equal, you write down equal lah. You don't have to write the full sentence. Tulis formula macam ni pun dah cukup. So if you go back, okay, kalau dia kata that this one is not equal, it is actually inelastic. Okay, you don't have to bother with this one. Tak perlu pun nak sebut okay perfectly inelastic collision ke tak. So dia tanya elastic or inelastic je. Okay, so you just have to answer that this one is inelastic. So since K initial is not equals to K final, it is inelastic collision. Okay, so remember, elastic or inelastic has nothing to do with whether the object moves together or not. Tak ada kena-mengena. You have to forget about that lah. So the only way to determine whether it's elastic or inelastic, you really need to calculate Ki and Kf. Itu je. If this one is not equal, inelastic. If this one is equal, it is elastic. It's as simple as that. Memang tak ada cara lain. You really need to calculate like this. Okay, the marks biasanya dalam 2 ataupun 1 je kadang-kadang. Tapi kena buat jugalah. Okay, last but not least, any question tak so far?
Sir,
Yes.
inelastic and perfectly inelastic sama ke?
Okay, kalau perfectly inelastic maksudnya this object after collision they move together at the same speed. Maksudnya dia melekat lah, dia melekat. Okay, but in this case, you can see that the velocity afterwards is not the same. So we didn't call this one as perfectly inelastic. Kita tak tulis perfect lah. Okay, katakanlah contohnya dia akan dapat sini 3, sini 3, and then you can write this one as perfectly inelastic. Understand?
So tak semuanya inelastic stick together lah.
Tak semua inelastic stick together. Yes.
Okay.
Itu benda. Okay. And then one more thing, perfectly tu kamu tak perlu pakai the term. You don't have to write it down. Even if kamu dapat 2, 2, 3 ke apa, jangan tulis lah. Bagi saya jangan tulis lah. Sebab kalau tak kamu salah. Kalau kamu tulis, dia salah. Kalau kamu tak tulis, tak ada masalah. Sebab soalan ni just tanya elastic or inelastic. Okay, kalau boleh saya tak nak sebut pun dalam nota apa pasal perfectly tu. Tapi sebab dalam nota ada, so saya kena cakap jugalah. And then the important thing here is that, ingat saya ulang balik elastic or inelastic has nothing to do with the condition whether the object stick together or tak stick together. Tak ada kena-mengena. The only way to determine the elastic or inelastic is due to the kinetic energy, whether they conserve or not. Itu je. Which is going back to here lah. This is the most important part. Okay, understand?
Yes, sir.
Alright, good, very good. Okay, last part before we go to the experiment. I just want to show what happen if you have two-dimension punya collision. What if what will happen is that to solve this one is basically the same, except kita kena buat X and Y tu separately. Okay, contoh Okay, I didn't put any number because saya tak nak kira pun. Put this one as A and B lah. Okay, let's say this one is the case before collision. And after, let's say this object now move in this direction and the other object move in that direction. So that you have VA and VB in that direction. So what you guys need to do is that you can solve this one using conservation of momentum, but you have to do PI for X and PI for Y. Apa saya cakap ni? Okay, so basically you have to separate X dengan Y component tu separately. So macam mana kamu nak separatekan dia tu? Contohnya dekat initial ni, kan? You can see that all the velocity is in X component. UA to the right, UB to the left. So nothing to do with Y component. Tapi dekat sini kamu ada Y component. So actually you have to add a little bit more dekat subscript dia. UAX, UBX, okay, and then VBX, and then VBY. Okay, this would be VAY. Then you will have VAX. Okay, so kalau kamu nak masukkan yang dalam formula ni, X component, you only need to consider this one, this one, this one, this one. Okay, so dekat sini yang dekat VAX dengan VBX tu you will have a V cos theta lah, contohnya. Tapi dekat UAX dan UBX tu dia just a solid number, tak ada cos pun. Boleh bayangkan tak?
Boleh, sir. Boleh.
Boleh. Kalau untuk Y, dekat sini tak ada Y, dekat initial tak ada Y, after tu ada Y. So what will happen is that this one will be equals to 0. Yang initial momentum untuk Y component is 0. And then the final tu kamu kena substitute yang VBY dengan VAY. Again, this one will have a sign lah. Kalau ke atas positif, ke bawah negatif. And then you substitute these two basically over here. Okay, it's okay. Kalau tak faham pun tak apa, don't worry. Nanti kamu dapat soalan tutorial, maybe you can understand. Okay, what you guys need to do after this is that you can do the tutorial question. Dah boleh buat semua lah. So basically momentum and impulse ni saya dah cover the whole chapter. Any question before we moving on?